Alright, hello again. This is Jeff Scott for the 152-143 Beginning Java Programming class for the Spring 2016 semester at Blackhawk Technical College. I'm now going to be going over Chapter 2, which is entitled Java Fundamentals. As mentioned previously, I'm going to go through probably 10 different chapters in here, and I'm going to do all of the PowerPoints first, then I'll go back and go over the book. My goal is to have this done by Christmas and have it all out there on the system for you. So if you do want to look at it during the holiday break or the winter break, you'll be able to, although by no means do you have to. So the different topics that are discussed in here are the use of print and print line. We'll talk about those in just a second. The Java API, I'll show you that. Variables and literals, the 8 different primitive data types you have in Java. The arithmetic operators, plus, minus, multiply, divide, and modulo, which is the remainder operator. Combined operators, creating constants by using final. The string class, and what's interesting about that is if you notice, string is not a variable type. String is the name of a class. All right. We'll talk about variable scope, how to create the 3 different kinds of Java comments, a couple words about programming styles, and the chapter ends by discussing and kind of comparing and contrasting using the scanner class for input versus using dialog boxes. So, a Java source code file contains one or more Java classes, but only one of those classes may be public. You can have embedded private classes, so you could put private classes inside of a public class. I don't think we do that until the advanced class. Again, the public class and the name of your file must match exactly. So if you say that your class is named simple as they show here with a capital S, it must be saved in a file, simple.java with a capital S. Each Java class can be separated into parts. Again, don't worry about the compilation that they talk about here. We're not going to do it this way. So again, here is a simple Java program. Public class simple. You'll notice at the top of the page you've got 2 forward slashes followed by this is a simple Java program. Well, forward slashes, 2 forward slashes means that the rest of the line is going to be a comment. If I go back to that Java program I showed you before, and let's say that I wanted to put a comment in here that says I'm beginning this. So I could come in here and say // you might notice it turned green, and now I can say begin followed by this. Then at the bottom, // end followed by that. / begin followed by that, / end followed by that. In fact, I usually put comments in there like this. Try to put a beginning and an ending comment by every curly brace that I have in there. All right. If I wanted so let's say that I wanted to put a comment over 3 lines. All right. And I wanted it to say 3-line comment, but I wanted each word to be on a line by itself. I could do this. I could say 3-line comment. And there's absolutely nothing wrong with doing that. That's totally fine. But if I want to, I can show a multi-line comment by starting with a /* and then ending with a */. And then I don't need all these other things. You know, and I can put stuff, I can put, blank lines or whatever the heck I want to put in there, I can put in. All right, so you see some examples. There is another kind of Java comment that we'll get to in a bit. It's called the java.comment. That starts with a /*, and you may or may not be able to tell that's blue. All right, and there you put in different information. Okay? All right, we'll get to all this stuff in due time, so if it seems like I'm going quickly, sorry. If it seems like I'm going too slow, sorry. Ideally, for some people, it'll be a little fast. For some, it'll be a little slow, so hopefully, for the majority of people, I'm going at around the speed you want me to go. All right, so public class simple, as it says, what appears then between those curly braces that you see, that's the body of the class that's named simple. So it'll hold all of the data and all of the methods for the class. We will always have a void method, which is what this is. It doesn't have to be the first method. So if you've got several methods, it does not have to be the first one. Some Java programmers always make the main method their first method, but by no means do you have to do that. And as it says, this line right here, public static void main, etc., that's a method header. And then there's curly braces, and what's inside of there is the body of the main method. So between these two curly braces are the body of the simple class. Between these two curly braces are the body of the main method. That system.out, programming is great fun. As it says, this is a Java statement that's going to be executed when the program runs. This is very simple to what we did before. Now here it says programming is great fun. If you remember the one that we did earlier, we had hello world. If we remove this line and we say system.out.println and we say here programming is great fun. Okay, and I run this, so I'm going to save, run. There it is. Programming is great fun. All right. Again, remember, you're going to get hit from this in several ways. I'm going over the PowerPoints. When I get done with the 10 PowerPoint presentations I'm going to do 10 more when I go right out of the book. So that'll be 20 lectures. And there will be at least one and sometimes two for each chapter that we'll go through in class, where we'll actually do one or maybe even two programs. All right? Comments, I already mentioned, they're ignored by the compiler. The example that was there with the 2 forward slashes was a single line comment where it said public class simple. That's our class header. That class header must be between, what follows there must be a set of curly braces. Then within those curly braces we had our main method. As it says, this line must be shown done exactly as shown in the example, except you don't have to call it args if you don't want to, although basically everyone does. All right. Every Java application, and remember this semester all we're going to write are Java applications, must have a main method. When the program runs, all right, the statements within main are executed. Statement must end with a semicolon, so there's only one Java statement in this program. It's the system.out.println. Everything else that's in there, as mentioned, is either a comment or it's some other kind of Java code. Comments do not need semicolons. Class headers do not need semicolons. Method headers do not need semicolons. Curly braces do not need semicolons. Virtually everything else does. We already mentioned earlier that Java is a case-sensitive programming language. As mentioned there, all Java programs must be stored in a file that ends with .java, and it must be the exact same name and caseness as whatever you call the public class in the file. Comments are ignored by the compiler. A Java program or a Java file can have many classes, but only one is public. All the rest have to be what are called private classes. If the Java file has a public class, then the name of that file must be exactly the same, including the case, as the class itself. Java applications must have a main method. Next semester we'll talk about Java applets. Java applets do not have to have a main method. In fact, typically, Java applets do not have a main method. For every left or opening brace you have, there must be a corresponding right or closing brace. All right? All Java statements are terminated with semicolons. This is all review. So here were the characters that you saw inside of that program. The // which was our comment. The parentheses, which held our parameter list for main. The the curly braces, which encloses a group of statements, quotation marks, which you use for strings, and semicolon for the end of a programming statement. Don't worry about the console. What we're basically doing, what they show here for the console window, in our case, is basically what we're writing down here. This is our console. In fact, you can see it's called console. That console is known as our standard output device. The input device by default is going to be the keyboard. All right, as it says, Java sends information to standard out by using a Java class stored in the Java library. Now, they talk here about the Java API. API is an acronym that stands for Application Program Interface. For lack of better words, it's kind of a contract that the programming language has with you that says, I'm going to give you all this code that I've created, but you have to agree to use it in the way that I've specified it should be used. So if I go out here, and I bring up my browser of choice, and under my browser of choice, sorry, when I work at home and I've got a lot of stuff open, this goes very slow. But if I type in java.sun.com, which I believe I mentioned to you earlier, that brings me out to Oracle's Java page. Then if I go down on this first column here, the second thing down says Java APIs. So I click on there. And I can just grab the newest one, which is Java SE8. They're all pretty similar to one another. So if I wanted to find out more about strings, I'd go down to my classes, and I'd go down in alphabetic order till I found string. There it is, and I'd click. And if you notice in here, this is my content area, and there's a lot of stuff in here that's all about strings. This is the Java API. This is the Java Application Program Interface. And again, if I want the newest one, I'm going out to right here. It's a little hard sometimes to read, so let me make it a little bigger for you so you can hopefully see it. So if you want to do some investigatory work on your own to see what's what in here, you can go out there. http://docs.oracle.com/Java SE for standard edition /8 because it's version 8 /docs for documentation /API, the application program interface. All right, there it is. As they mentioned, the line of code that we had said something like system.out.println, programming is great fun. What this is, that's a class. System is a class that exists in the standard Java library. And what, when you think about a library, at least when I do, I think about, well, it's a place I can go to take out books. All right, so I can borrow them, use them as I need them for as long, typically, as I want to, and then return them. Well, in sort of the same way, in the Java library, it's a set of routines that I can add to any of my programs and use them in my programs. So the system class, as mentioned there, contains methods and objects to perform things at the system level. There is an out object in there, and out has among it print and print line. What's the difference? Print line prints this and then puts the cursor on at the beginning of the next line. Print without the ln would leave the cursor right here. As it says, this is really pronounced system.out.println. They'll give you a bunch of examples in here. Here's using it over 2 lines. Here, this is going to print on 1 line. These lines will be, since it's a print, it'll stay right there, and it'll type in printed on, and since it's a print, it'll stay right there, then the same line. Then it'll go down to the next line. So even though there's 3 print statements in there, it'll all print out on 1 line. And it says, why are some words run together? Because we should have had a blank space either there, or there, either there, or there. Now sometimes you do this and you don't want to use System.out.print line. So in other words, if I had said this, System.out.print, all right, so I've changed it from print line to print. I'm going to save it, and I'm going to run the program again. It doesn't look any different, but technically right there, that is where my cursor is. If I want it to go to another line, I can either change this from print to print line, or at the end of this I can put a \n, which is a new line character. So now when I do a run, now my cursor is actually right there. The \n is an example of what's called an escape character, and there are several that are shown in the book and on this slide right here. Probably the two you're going to use almost exclusively are the first two. \n for new line, \t for tab. All right, the other ones you might have reason to use, but actually quite a few of them you might never have reason to use. So there's a bunch of examples here with System.out.print, with tabbing, etc., so you can look at that at your leisure. All right, we talked about variables and literals earlier, and you did see, not in the example that we currently have, not this one, but if you remember what we first wrote out on here was, we said string message equals hello world. And then we had System.out.print line, and what we put in here was message. All right. This is a variable of the string class. It's called message. This is saying what I want to print out on the screen now is hello world. You notice we've got programming is great fun there, but that's from the last run. If I do a run, it changes to hello world. Again, remember that in memory, it's not the number 5. It's actually going to be 0000011, which is the binary version of the number 5. I'm sorry. It'll be 00001. It'll be 4 zeros. Actually, it'll be 5 zeros, and then a 1, and then a 0, and then a 1. That's what it'll look like. All right, if you did it like that, that will print out literally. It'll say the value is 5. And you notice the word value you don't put within double quotes, because if you put this value that's right here within the double quotes, it would say the value is value, which wouldn't make a lot of sense. You use plus in two ways. You use it either for addition. All right, so x equals 7 plus 3. That's used as addition. Here, we're using it as concatenation. Since you can use the plus as both an addition operator and as a concatenation operator, the plus operator is also known as an overloaded operator. We're going to talk about overloading in a few chapters. So they show you, I already mentioned that to you before, using the plus sign, etc., to put stuff over multiple lines. Okay, he goes on and on about concatenation, and it's all fine. All right, we talked in the first chapter about programmer-defined identifiers. And as it says, those are names you give for variables, for methods, and for classes. And they can't be the same name as a keyword. So here's the rules. They can contain only letters, digits, underscores, or dollar signs. And the first character must be either a letter or an underscore. Now, long story short, if you have all of your variables contain only letters, or only letters and then you might mix in some digits, you're best off. Don't use the underscore, don't use the dollar sign. Those are typically used for system type of variables, and there's really no reason for you to do that. Identifiers are case sensitive. So as it says here, items ordered with a big O is not the same as items ordered with a little o. You cannot have blank spaces in identifiers. Again, here's your reserved words. We talked about this a little bit earlier. So there's about 40, somewhere between 50 and 60. These are keywords. So I cannot create my own variable and call it false, or for, or go to, or finally, etc. Again, out of this list in here, we'll probably end up going through about half of them. Okay? Those are the ones that you're going to use virtually all the time. Ideally, when you create variables, their names will be self-documenting. As it says right here, TR is not nearly as self-documenting as sales tax rate. And I want you to use this. Remember when we created a class before, if we had like two words together, if this was a class, not a variable, if this was a class called sales tax rate, that S would be uppercase. But when you're creating a variable, you run words together like this, and the first word is all lowercase, and then the first letter of every word that follows is uppercase, and the rest is lowercase. I do want you to come up with program variable names that are self-documenting whenever possible. All right, and here's, again, variable names like this, class names like this, and it says you can find more about naming conventions. I'm not going to click this. Okay. A general rule of thumb, it says about naming variables and classes, with some exceptions, the names are usually nouns or noun phrases. All right, here are your 8 primitive or simple data types that you have in Java. All right. Out of this list, byte, short, int, long, float, and double. Those 6 are all numeric variables. Boolean and char are special variables. Not only that, the 4 in this column, byte, short, int, and long, these are all integer or whole number variables right there. Float and double are variables that can have a decimal place. Boolean is true, false, and char is a single character. So when you look on the numeric stuff here, the 6 numeric types, here are their ranges. So notice a byte, negative 128 to positive 127. A short, negative 32,768 to positive 32,767. And int, negative 2 billion plus to positive 2 billion plus. A long, that's a bigger number than I can comprehend or try to read to you. Float and double, notice the big difference. Double has 15 digits of accuracy, and a float has only 7. This goes to the 38th power. This goes to the 308th power. All right. So typically when you create variables, they'll be like this. Okay. Again, byte, short, int, and long are all integers, so they hold whole numbers. Floating points go into either double or float. All right, and just so you know, you're probably very rarely going to use type float. So let's say I wanted to come in here and I wanted to type in a variable and I wanted to call it float, or type float, and I wanted to call it salary. So float salary equals, and let's say the person made $55,000 a year, and I hit enter. Well, wait a minute, that looks wrong. Oh, it's because floats have to have a 0.0 on the end, right? That's why I got that. No. This isn't an error right here. What it's showing us is before we put the 0.0 in there and we had it like this, all right, it was yellow. What that means is you've declared a variable that you're not using in the program yet. But if I put in here 0.00, I get an error message. Because when you use a float, Java needs you to have to put either a lowercase f or an uppercase f. You have to do that when you're giving values to floats. But if you don't want to do that, yes, it's way too much work, then make it a double. Then you won't get the error. So what you'll find is virtually all of the time in this class, when I'm creating variables like that, I'll make them type double. It just makes, it's easier to do. It's less work. It's It's less worry. All right. Again, 23.5F, example I just showed you. Do not ever, when you're giving values to variables, never put in $signs, commas, etc. Never do that. You can put in a decimal place, but only if it's a double or a float. You can also use scientific notation if you need to do that. All right? I won't, because there really is no reason to do that. Booleans, again, can only hold the value true or the value false. And when you're creating a Boolean variable, literally you say Boolean. All right, so notice if I say Boolean, let's call it married. And I can say in here now either true or I can say false. But those are the only two values. I can't put in, for example, 37. That doesn't make any sense to the system. And what it's saying basically in here for the error is, wait a minute, that's a Boolean. You can't convert from an integer to a Boolean. So the only thing this will take is true or false. All right? A char is a single character. You might look and go, wait a minute, there's two characters here, Jeff. No, that's the backslash isn't counted as a character. All right? You can also do things with Unicode because Java supports the Unicode coding standard. Does that really matter? Well, it's a character set, which means that originally the only character set that was available for people to use was the ASCII character set, the American Standard Code for Information Interchange, which only had 255 possibilities, which was fine because it handled everything in the English language. But as we started to cascade and have more languages, 255 wasn't enough. So they created the Unicode character set. And actually this is a little old because the Unicode character set now has over 100,000 characters in it. All right? So basically it has all the characters for every language that currently exists. Okay? And there's even some left. So there's an example. All right. Characters, as it says, are always going to be stored as binary numbers. Okay. All right. I already mentioned to you before about variable assignment and initialization. Now, the author of this book, what I showed you before was I said, if I say this, let me just remove this for a second. If I say double salary, that's a variable declaration. And then if later on I say salary equals $55,555.55. All right? Then, so this is a variable declaration. This is a variable initialization, or what the author calls a variable assignment. Most of the time, you grab these things that are in here and you do them together. Okay, but you don't have to. What's on the left-hand side of the equal sign must always be a variable. It can't be a literal. In other words, I can say x equal 12, but I can never say 12 equal x. Doesn't make any sense. Variables must be declared before you can use them. If I were to come in here, if you look at the example that you see right here, in fact, let's grab this example. All right. I'm going to purposely make a mistake. So I'm going to grab all of that code that you saw. In fact, that's too much. Let me grab everything that's inside of main here. So let me grab all of this stuff. So I'm just going to grab everything there that's in main. All right, like I said, I'm purposely going to introduce an error here. So I'm going to grab everything that's within main. What's currently in there, I'm going to remove it, and now I'm going to paste in this new stuff. Well, that didn't work very well, did it? See? So let me grab it again. Copy. Let me throw it into Notepad first to try to get rid of that junk, all this junk that's in there. So let me look at what's in here and try to fix it. Take me just a second. All right. Why it's doing that? Getting weird stuff happening here. Like I said, I'm purposely going to introduce an error in here. So even though it'll be an error, don't worry about it. We'll look at it and we'll look at how to fix it. First of all, I don't like what the author does here. This says int month, comma days. I always want your variables, each one to be on its own line. So if that's going to be int month, I want that to be, whoops, int days, like that. All right. All right, now I'm going to grab all of this code, and it's going to print out just fine. There won't be an error, but then I'm going to introduce an error in just a second. So let me put that in there. So there's that stuff. This should come out and say month 2 has 28 days. If it works correctly, it should say month 2 has 28 days. So let's see if indeed it does. Save. And run it. Month 2 has 28 days. Not a problem. Now what I'm going to do is I'm going to try to print this. In fact, let's just, I'm going to try to print this before I've given month and days values. See, notice it's giving me an error already. It's saying you didn't initialize your variable. Well, I don't care. All right, I'm going to run it anyway. It says, do I want to proceed? Normally I'd say no here, but I'm going to say yes. All right, and it's giving me an error message. So when you look down in your console window here and it's red, that means there's problems. What I have, it's literally what's referred to as a null pointer exception. And what that means is I've declared a variable here, but I haven't given it an initial value. But even without an initial value, I'm trying to print its value. The system doesn't understand that, so it gives me an error and it refuses to go on. Bottom line, variables must be declared before they can be used. Variables must be initialized before they can technically be used. So once declared, they can receive a value. However, the value must be compatible. You already saw that before when I went in, for example, into that boolean variable called married, and I tried to put 37 in there, and the program didn't like it. After receiving a value, variables can be used in output statements and in calculations. These are local variables. If you declare a variable inside of a method, remember this name of this method is main, so any variable that we declare in here by default, unless told otherwise, is only available inside of these curlies. If I declare a variable at the top of my program, so in other words, going back to this example, I can declare variables here. So I could declare a variable here called age. And that variable is available inside of main, outside of main, and anywhere in the whole program. That has to do with what's referred to as variable scope. Again, we're going to go into all this stuff as we go on in here in much more depth and breadth of coverage. Variables can only hold a single value at a time. Local variables do not get a default value, so you must initialize them. It says here, trying to use an uninitialized variable will generate a syntax error when the code is compiled. You already saw that when my console screen turned red. All right, here's our arithmetic operations. Addition, subtraction, multiplication, and division should look pretty similar. You should have had modulus, which is the remainder operator. You should have had that in the JavaScript class. Typically, modulus is used for time, hours, minutes, seconds, or dollars and cents, or whatever. Arithmetic operators are binary operators because they need two operators, or two operands, I should say. It's an error to try to divide a number by 0. When you work with integers, it says the division requires special attention. In other words, if I come through here and do this, so let's just say I'm going to write a simple little program. I'm not going to write my public class and my main, but let's just say I'm inside of main, and I write in this. Int x, how about int number 1 equals 5. Int number 2 equals 2. Double answer equals number 1 divided by number 2. Now you might think, looking at this, well, 5 divided by 2 is going to be 2.5. So that's what's going to print out here for answer, but that's incorrect. What happens in Java, like virtually in every other programming language, is when you divide an integer or a whole number by another whole number, it throws away the decimal. And then it says, oh, it's a double. So it does that. So if I want to force this to happen, okay, if I want to force my answer to be 2.5, I can do this. So this won't work. That's what this will give you. But if I do one of the following, it will work. I'm going to show you, we put about, I can do what's called cast. So I can say here, well, I want to make that a double. So I can do that, or I can do that, or I can actually cast them both. All right. Those three examples that are here are all going to give me, in that case, they will say 5 divided by 2 equals 2.5. All right. And there's their example of integer division. It says in a Java program, what is the value of 1 divided by 2? Technically, it's 0. Again, integer division will truncate any decimal remainder. Here's the order of precedence. This should be something that you learned back from your days in high school algebra. All right? You do multiplication, division, and modulo before you do addition and subtraction, bottom line. If you want to get around that, you use parentheses. Java also has combined assignment operators. So let's just look at the example that we had before. All right? We'll just keep these. And in fact, I'll get rid of all this stuff that's in here. So I'm going to say int answer equals 0. All right, so I can say something like, whoops, that should have been int, not in. All right. Okay, so I can come in here and I can do something like this. In fact, I could have said right here, int answer equals number 1 plus number 2. Now answer's got a value of 7. That's not a problem. If later on in my program, I want to say this, number 1 equals number 1 plus 17. Totally legit. Now number 1 would be 5 plus 17, or in other words, number 1 would now have a value of 22. All right, but there's a shortcut for doing that. I can also just say, if I don't want to write it like that, I can say number 1 plus equals 17. So that statement right here and that statement right here are the exact same thing. It's just that the second one involves a little bit less typing. It's called a combined assignment operator. And you can use it plus equals, minus equals, times equals, divide equals, and modulo equals. All of them will work. What I always tell students is in the first year of the program for understandability. If it makes more sense to you to go and key something in, even though this is shorter and involves less typing, if this makes more sense to you as opposed to this, then do it this way. It's more important to me that you understand what's going on, not that you save some keystrokes. All right, let's talk about constants. A constant is something whose value cannot change once it's been set. So let's say that I'm writing a program, and in that program I want to create a tax rate. And I want that tax rate to be 7.5%. All right, I could come in here and say this, double tax rate equals 0.075. But that's not a constant. I can go in and change the tax rate later on in the program if I want to. But if I come through here and do this, and I type in final double, and typically this is going to be a constant, so constants are in uppercase, equals 0.075. The difference between this one and this one, forgetting about the caseness in the names, this one is a variable, so it's changeable. This is technically a constant, is a variable, but you cannot change its value once it has been set. All right, and that's exactly what the author talks about on this slide. All right, I don't like having the underscore there, but if that's something you really like and you want to do that, again, we'll talk about this at the end of the chapter, but that all has to do with, when you're doing all this stuff, this all has to do with programming style. All right, remember, strings are not a data type, they're a class. You use the uppercase S. Why? Because you start classes with an uppercase letter. All right. So they talk about primitive versus reference variables. The big difference between these, all right, is a primitive variable is a simple data type, and a reference variable is what's referred to as a complex data type. All right. So if I say string city name equal Charleston, what you're going to find probably in memory, if I go to that location where city name is not Charleston, but I'm going to find an address. And if I go to that address, I'll find Charleston. If that doesn't make sense to you, don't let it worry you right now, because again, we'll go over it. All right, I do want to mention, if you look right here, they've got, this is a perfect example they put on this page. Typically, if you create a string, you'll do it like this. String value equals double quote hello double quote. But what really happens behind the scenes is this. String value equals new string parenthesis double quote hello double quote parenthesis, because strings are objects. That's creating a new string object named value. An object is a member of the class, so value is an object of type class string. Strings have different methods, different things you can do with them. So for instance, if I were to do this, if I came into the program that I've been working with here, so just so you can see it. So I'm going to say here, string first name equals, oops, it's got to be in double quotes, Jeffrey, which is my first name. All right. So if I come out here now and say System.out.println, and now I come in here and say name is plus first name, okay, it'll say name is Jeffrey, and then on the next line I want to say System.out.println, it has plus first name dot length characters. I think I put that in there syntactically correct. We're going to find out right now. All right. Why I put that on the end, I don't know. All right. So hopefully that is all okay. Let's see. First name dot length, does it want paren there? I didn't think it did, but it might. Let's go back and double check that here. Oh, I do need the parentheses, sorry. All right, so paren there, because this is a method call. All right, so now let's save this and run it. And let's look at the output. Name is Jeffrey. It has 7 characters. All right, character 0, character 1, character 2, character 3, character 4, character 5, character 6. But if I count from 0 to 6, that is 7 characters. There's different string methods. Strings are what are known as being immutable. Do you have to worry about that? Not for right now, but I'll show a better example of what I mean when we get to the actual chapter stuff. Scope is where something is known. I've already mentioned this to you, that if I declare a variable right underneath my line that says public class followed by the class name, so in other words, if I declare a variable that's not inside of any method, it's a global variable, so it's known throughout the whole program. If I declare a variable inside of a method, inside of main, or later we'll write other methods other than main, that's a local variable, so it only exists there. All right, we talked about comments before. Okay, so I don't really feel the need to go over that right now. If you use a Java doc comment, the last type, you can write comments that look more like the comments that actually exist in the Java API. All right, programming style. You can write a really ugly program, and they show this in the book, where you squish stuff together. So in other words, I could actually go to this program that we have right here. Okay, and as an example, I could put these things all on the same line, and this on the same line, etc. So I've got that string. Notice all the stuff I put on the same line. All right, I'm going to save this and run it, and I still get the same output. All right, would I want to do that? No, because it's much easier to read this, look at it, work with it syntactically when it looks like this. So that's programming style. That's the use of white space, all right, tabs, etc., to make your program look as aesthetically pleasing as possible. It also involves indentation when necessary. All right, so the last thing that's discussed in this chapter then are they talk about the scanner class, and they talk about the using input dialogs. I'm just going to briefly go over this because when I show you what's in the book, we're going to go over it much more depth and breadth of coverage. Okay? Scanner supposes that you're going to read something in from a keyboard. So in other words, if I do this, if I import java.util.scanner, this says that there's something that exists for me in Java. There's a special class called util, which has utilities in it, and one of those utilities is scanner. And if I use that, I'm going to be able to write stuff like this. Okay? So when I use stuff like this, what that's going to mean is, and you've seen a little bit of this already, that it'll come up like here and it'll say something like enter your name. Then I'll put in Jeffrey. Then it'll come back and say it has 7 characters. All right, so I'd have to come up here and I'd have to say import java.util.scanner. All right. I thought that's what it was. That wasn't it java.util.scanner? Maybe the scanner is capitalized. Okay. Okay, so I've got that now. Import java.util.scanner. So now if I come in here, I just want to make sure I'm using the right syntax. So I grab this. I can create a new, what's called a new scanner object, and put that into my code here, just like that. And I can set it up then so that when I do that, it'll come up and it'll ask me to enter my first name. I don't know if they show that in here or not. No, they don't. All right. We're going to look at that, and I've got an example that I've already written, and I'll put it out there for you a little bit later so you'll be able to see it. But that's probably going to be the only time we're ever going to use this, because typically you'll want to use dialog boxes. Dialog boxes are as close as we get to GUI, graphical user interface, in this semester. We'll use message dialog boxes to display output and input dialog boxes to display input. When we use these things, we have to do what's called import, another import statement. So we looked before, and when we did an import of java.util.scanner, we needed that so we were able to use the scanner class. So notice, if I leave this out, I'm going to purposely remove that line. So I get an error message here. It doesn't understand scanner. But there is a shortcut for this. What I can do is I can put my mouse over this and the system says, well, here's a quick fix. Do you want to import scanner? So if I click that, it adds it back for me. All right? And you'll see some of this stuff as we go on throughout the semester. So here's a message dialog. That's an output. Here's an input dialog. That's an input. All right? So we're going to go through all those. You see it's got null right here. When you put null there before whatever it shows, that just means put it right in the middle of the screen. All right? So we'll work with input dialogs. As it says, an input dialog is a simple and quick way to ask the user to input data. It's got an OK button on it for when you're done. And it's got a cancel in case you change your mind. And you can program for both of those. All right, so this is how you do it. This is going to come up and it's going to say there, enter your name. You put a name in there, you click OK, whatever name. So if I put Jeff in there, that'll be what gets assigned to name. All right. Finally, the System.exit method. What happens when you're working with these dialogs is the system doesn't know necessarily that it's supposed to be done. The program is finished. So you'll put in System.exit at the end. And if you want to show that it ended normally, you'll say System.exit 0. 0 traditionally indicates successful program termination. All right. All right. These parse methods, again, you're going to see examples of those when I go through the examples in class. All right, here's some examples. You're going to see them in a lot of depth and breadth of coverage. Okay, so you're going to see better examples than what are shown right here. That's pretty much it for Chapter 2. So when I go on next, it'll be into Chapter 3, and Chapter 3 will be on decision structure, so it'll talk about if else if else, and the switch statement. So that's all I've got for right now.